are in quarantine or something like that. Okay, need to share the screen. And so I am going to record the course or record the class today for that reason. And I'm going to start with this PowerPoint about chi-square goodness of fit. It is not currently in D2L, but I'll post it there later so you can look at it, okay, and have it. We're actually continuing our discussion of hypothesis testing and those steps that we've looked at where you state your two opposing hypotheses. You identify the information that you need for the problem, determine which distribution or which test you're going to conduct. Step 4 is to actually calculate that test statistic and its corresponding p-value, then make a decision and write your conclusion. Those 6 steps that we outlined last class, we're still going to use today, but we're going to apply it to a different distribution or a different test statistic. We're going to talk about specifically chi-square goodness of fit. The chi-square distribution actually has 3 different uses within statistics. And if you opt to take the next course, Math 2401, which is intermediate statistics, you'll actually get to talk about the other 2 ways to use chi-square. We're only going to talk about one of them. But the 3 ways that the chi-square distribution can be used, one is it can be used to test a claim about the population variance or the population standard deviation. Remember, I mentioned to you previously that when we conduct hypothesis testing, it's based on a population parameter, and that our primary focus would be the mean. But we could make a claim about the variance or the standard deviation for the population, and we would apply or use the chi-square distribution. The second one is called the chi-square test of association. And we test whether 2 characteristics within a population are maybe somehow associated. You know, is your age associated to your blood pressure? Is your height related to your weight? Are they somehow associated? It's called the test of association. The third one, which is the one we're actually going to focus on in this course, is when we compare a frequency distribution of observed behavior to what theoretically is expected. In other words, we want to know, does the frequency distribution, does the data fit a specific pattern? And that's called goodness of fit. And we will get the thing started back up in just a minute. I have no clue why it does that. Okay, so we're going to talk about that. So we're going to look at how a particular set of data behaves. And the one thing that's different about the chi-square distribution, at least the one we're looking at in terms of goodness of fit, is that it applies to qualitative data. See, up to this point, towards the end of Module 1, we talked about qualitative data, where you had words and phrases. And then I told you that we would turn our attention primarily to quantitative, to numbers, throughout Module 2 and Module 3, and we've done that. But as we begin Module 4, we're coming back to qualitative data, words and phrases. Okay, so let's talk a little bit about this chi-square distribution. Again, it has three uses. We're only going to focus on the third one, which is called goodness of fit. How well does our data fit a particular pattern? Some examples where you might use goodness of fit, so hopefully you can make a connection. One might be within the world of business, to meet customer demands, a manufacturer of running shoes may wish to see whether buyers show a preference for a specific style. Do they like a particular style of shoe? Do they like a particular color? Because obviously, if one shoe is favored over another, then they may need to make more of that favored shoe than they do of others. And so that would be a way to see, is there a particular pattern within how the shoes are purchased, how buyers purchase the shoes. A second example is a traffic engineer may wish to see whether accidents occur more often on some days than others. That may help with staffing, with positioning perhaps your emergency folks so that they can get to the accidents more quickly. Third is an emergency service may wants to see if it receives more calls at certain times of the day than at others. And again, that may help them with staffing and needs and that sort of thing. So those are some examples of scenarios where you might use chi-square goodness of fit to see if your data fits a particular pattern or has a particular pattern. So the chi-square distribution is quite different from the normal distribution or the student's t distribution that we talked about. The one big difference is that the chi-square distribution is not symmetric. It doesn't have that bell shape. It's actually skewed to the right. And you can see that there on the diagram, because notice how the hump, okay, is on the left-hand side. And when you have that peak on the left-hand side, that's called skewed right. The mean, or the average, is going to be just to the right of your peak. One of the other differences with chi-square is that your values of chi-square, your test statistics, will be 0 or positive. They'll never be negative. With the Z, or with the normal distribution, and the student's t distribution, because they were symmetric, we could have values below or above, so we could have positive or negative. With the chi-squared, the values have to be positive, or they could be equal to 0, but they'll never be negative. We talked previously how that the normal distribution, its shape is controlled or determined by the mean and the standard deviation. We talked about that the student's t distribution, its shape is determined by the degrees of freedom. The shape of the chi-square distribution is also determined by the degrees of freedom. It has a slightly different shape for each degree of freedom. Remember, degree of freedom is the number of values that are free to vary after your sample statistic has been computed. You really don't need to know that the formula, because Minitab is going to do it for you, but the formula for calculating the degrees of freedom is the number of categories you have minus 1. And if your degrees of freedom are greater than 90, so if you had, 91 categories or 100 categories, so that your degrees of freedom was 99, if your degrees of freedom is greater than 90, then the chi-square distribution actually approximates the normal. See, so we can get back to the normal if we have enough categories. Now that's probably going to be rare. I don't know of a scenario where you might have 100 different categories or 91 different categories, but it does, when you reach that threshold of 90, approximate the normal distribution. I know a couple of you are writing, so I'm pausing for a second. I'll post this in D2L so you'll have access to it. So again, our focus is going to be on the third use of chi-square, which is goodness of fit. And it is one of the few test statistics that can be used with qualitative data. Now, again, for us, because Minitab's going to do the work, it may not be as important as it would be if we were doing it by hand or using other technologies. But one thing to remember is the number of observed values that you're given must equal the number that you expect in theory. Okay? The number of observed has to equal the number of expected. These particular problems kind of fall into two different types. There's a scenario where you can have equal proportions, or they're divided equally into categories, or you can have specific proportions. Those specific proportions may be based on historical data, where you've maybe researched what's happened, in the past 10 years or the past 20 years. It may just be, could be your gut instinct, what you think it should be. Okay, so those are the two different types. The process is pretty much the same in terms of the setup. The command in Minitab changes slightly with the different types. And so you'll have to know whether you have equal proportions or specific proportions. I think that's the end of this. It is. Okay, so I want we're going to dive in to some examples and walk through several examples for chi-square goodness of fit. And we're going to start with equal proportions. Okay, so the first couple of examples that we look at will be related to having equal proportions. Okay, so here's our question. Turn it right side up. It says, the concessions manager at Mercedes-Benz Stadium wishes to see whether there is any preference in the flavors of popcorn that are sold during sporting events. A random sample of sales is selected, and the data are shown below. At alpha equals 0.01, are the flavors selected with equal frequency? Okay, a couple of things to talk about here as we think about this. The first step in the hypothesis test is going to be to state your hypothesis. Now, the way that you state it for chi-square is a little bit different from what we did before, because we're not talking about, that it's greater than a value or less than a value or different from a value. We're looking at whether or not this set of data follows the pattern. And the pattern that we want it to follow is that the flavors are selected with equal frequency. Oftentimes with chi-square, because we're dealing with qualitative data, which is words, the hypothesis will be written in words, okay? So you won't see as many symbols. And there's different ways to write it. The easiest way is to almost take that sentence there that we're trying to determine, are the flavors selected with equal frequency, and make that our hypothesis. Well, if they're selected with equal frequency, I hope that makes you think of the mathematical symbol equal. So should that statement be the null or the alternative? It's the null, because remember, we talked about last week that the null hypothesis must always contain equal in some form. And for chi-square, goodness of fit, it's going to be equal and not equal every time. With chi-square, goodness of fit, you don't have to worry about the less than, the greater than or equal, less than or equal. It's either going to be equal or not. It's going to be the same or not. Okay, so I would write the statement, the flavors are selected with equal frequency. Okay, now here's where it gets a little tricky, because the alternative is going to indicate that they're not all selected with equal frequency. Okay, but here's the question, guys. How many would have to be different in order for them not to all be equal? If I've got those four choices and I'm trying to say each one is selected the same, okay, how many of them would have to be different? Just one. So here's how you word it. We would say at least one, because if one is different, they're not all the same. You always use the phrase at least one flavor or flavors are, at least one flavor is not selected with equal frequency. We're trying to say that one of them is different. We're either saying, okay, and again, I'll put little comments up here, that they're all the same, or they're all not the same. Okay, so it's a little bit different in how you word or how you state your hypothesis. It's not stated in symbols. Okay, it's stated in words. And the statement in the null hypothesis will always indicate that they're the same or equal, and the alternative will indicate that they're not the same or not all equal. Now, how you word that can vary from problem to problem, depending on what the scenario is. Okay, everybody okay? That's kind of the new little piece to this. The second step, remember, is we usually identify the players. Okay, well, you've really already been given the players, okay, because the players are the table that's given. Okay, I need to know what are the categories and how many are in each category. And the only other thing I need is my level of significance, which in this case is 0.01. Okay, so in the question, when the question is presented, you're being given all of the information. Now, I'm going to kind of show you something here that Minitab's going to do in the background, okay? I'm just going to make a note here that Minitab does it in the background, but I don't want you to think it's just magic. So the other piece that we need when we're calculating our chi-squared is how many do we expect, okay? In this table that you're originally given, this number sold is the observed. This is the reality, okay? On the particular day that they were collecting this data, they sold 25 plain popcorn, 18 barbecue, 32 butter, and 45 cheddar, okay? That was the reality. The expected is what we think should happen in theory if each one of those is selected with equal frequency. The way we calculate the expected is you take the total number in your sample times the proportion. Okay, the total number in the sample, let me write it out, total number in the sample times the proportion of each category. Okay, now I want to see if you guys can think this through for me. Okay, I got 4 flavors: plain, cheddar, butter, and barbecue. If they're going to occur with equal frequency, remembering it has to be a total of 100%, what percentage would you have for each one? Thank you, ma'am. Okay, got 4 choices. Has to total 100%. So 100% divided by 4 is 25%. So there's a 25% chance that a customer is going to buy the plain. There's a 25% chance they're going to buy the barbecue. There's a 25% chance they're going to buy the butter. And there's a 25% chance they're going to buy the cheddar. Does that make sense? Because you got 100%, 4 options. 100 divided by 4 is 25. Okay, so we would take our proportion for each category is going to be the 25% or 0.25. I need to figure out how many boxes of popcorn they sold total. So we had 25 plus 18 plus 32 plus 45. That's 120. On that particular day, they sold 120 boxes of popcorn. So 120 times 25%. We would anticipate if they're actually equal, that we would have sold 30 in each category. Theoretically, if we have equal frequency, I would have sold 30 plain, 30 barbecue, 30 butter, and 30 cheddar. Well, if you just look at it on the surface, you realize that doesn't match, right? I mean, it's obvious up there that all of those numbers are not 30. Like, none of them are 30. So the question becomes, how different are they? Are they different enough for us to say that one flavor is favored or liked better than another? Or can we say, yeah, even though the numbers are not exact, they still have equal frequency? We got to think about how different they are. And that's what the chi-square is going to do for us. Okay, now, Minitab is going to calculate this expected value behind the scenes for you. Okay, it's going to give it to you. But should you be in a situation where you don't have Minitab or you're using a different technology, you may need to calculate your expected. And that's how you do it. Okay, so we've got our hypothesis. We've identified our players. The third step, remember, is to decide which distribution. You really have three choices now. You have Z or T or chi-square, goodness of fit. Well, considering the topic of the lesson is chi-square, it's kind of obvious that that is. But the reason it's chi-squared, guys, is that we have qualitative data. The flavors of popcorn are qualitative. Plain, cheddar, barbecue, butter. Okay? So we know we need to do chi-square, goodness of fit. Nowhere in that paragraph for this problem does it talk about mean. Remember, the Z-test and the T-test are based on the mean. And nowhere in that paragraph does it talk about the mean. So I can nix them out pretty easily. And that only leaves one choice. All right, now we're going to do it. And we're going to use Minitab to do the calculations. So let me walk you through, because it's a little bit more to put in to Minitab. Okay, so step 4 is we calculate the test statistic and its p-value. And we're going to use Minitab to do that. Okay, the first thing that I have to do in Minitab is enter the given table. So for example, in column 1, I'm going to put the flavors. In column 2, I'm going to put how many were sold. Okay, you have to enter this table of information. That's the data. Okay, just like entering your raw data, but you have to enter that table of information. So I want to go out to Minitab and do that first. Got to open up Minitab for us. Now, if you already have data in column 1 and column 2, okay, you can use any two columns. I would put them side by side. Okay, so in column 1, I'm going to put the flavor. And I would have plain, barbecue, butter, and cheddar. Then in column 2, I'm going to put the number that were sold on this particular day. There were 25 plain, 18 barbecue, 32 butter, and 45 cheddar. Okay, so the table originally, okay, when I displayed it in the question, was horizontal. To enter it in Minitab, I had to do it vertically. Okay, everybody okay with that? I've entered the table into Minitab. Okay, then let me write down the strokes, the keys for you, and then we're going to come back and do it. Okay, so after we get our table entered, we go to Stat on the menu bar at the top. We're going to scroll down to Tables, and then we're going to choose chi-square goodness of fit. And I think it says one variable. Let me confirm that for you. Stat, tables, chi-square goodness of fit test, one variable. Okay, so we go Stat, tables, chi-square goodness of fit. Okay, then your wizard comes up and you have to indicate where are the observed counts what is your categories. Where are your categories? So for us, we put our observed counts in column 2. My categories are in column 1. I then have to choose whether I have equal proportions or if I have different or historical proportions. Again, this one's equal because the statement was equal frequency. So we choose equal proportions. Then we choose our options button like we always do. You're going to enter the confidence level, okay, and choose not equal, I believe, all the time for the hypothesis, because not equal, remember, is at least one is different. Okay, so here we go. Let me start over. I entered the data. We go to Stat at the top of the menu, at the menu bar, scroll down to Tables, chi-square goodness of fit, one variable. If you'll click in the box next to observed count, there, that's my numbers. That's in column 2. My category names are in column 1. I'm doing equal proportions, and I click OK. Okay, so I didn't have to enter I don't have to do this last step. I'm sorry. Okay, so you can go back and mark off that last step about the options. I'm sorry. All right, now you get lots of information here. Okay, let me see if I can make this bigger where you guys can see it. Maybe I can. Probably not. Okay, notice it kind of recreates our table. It has our categories, then our observed. It shows the proportion, which we talked about being 25% for each category. It gives you your expected, and then it gives you your contribution to chi-square, which you don't really need. What you ultimately need is under the header chi-square test, you need chi-square, which is 13.2667, and the p-value is 0.004. So that's what I need to write down. Okay, so I need to write down, and I'm going to write the symbol for chi-square, and then I'll show you how to write it. Okay, my chi-square goodness of fit is 13.2667, and its corresponding p-value is 0.004. Okay, so I wrote those things down. Your symbol for chi-square is the Greek letter chi. It looks like a fancy X with an exponent of 2 to show that it's squared. Chi-square. Greek letter chi looks like a fancy X, exponent of 2, and then we use GOF for goodness of fit. Okay, so we have our numbers. Then, if we move to step 5, where we need to make a decision, we're going to make a decision doing the same thing that we were doing last week. We're going to compare the p-value that we just got from Minitab, which is 0.004, to the alpha that was given in the problem, which was 0.01. We're going to make that comparison. So let's see, 0 compared to 0, there's no difference. 0 compared to 1. 0 is less than 1, so P is less than or equal to alpha, which means we reject the null. Okay, so there's our decision. The last step, remember, is to write your conclusion. And your conclusion is always written in terms of the null hypothesis, okay? Always in terms of the null hypothesis, and it includes your level of significance. So we would start out saying at the 1% significance level. Okay, now let's go back and think about this for a minute. We have said that we're going to reject the null. If we reject the null, that means the null is false, which means the flavors are not selected with equal frequency. Okay, so I need to say that in my conclusion. So we would say at the 1% significance level, the popcorn flavors are not selected with equal frequency. And there's your conclusion. Now, the one thing that chi-square goodness of fit does not tell you, we just concluded that the flavors are not selected with equal frequency. So then the question becomes, well, which one do people like better? You know, like what's the top choice? Chi-square goodness of fit doesn't tell us that. In order to make that determination, we would have to start comparing flavor to flavor. We would have to compare the plain to the barbecue, and the plain to the butter, and the plain to the cheddar. Okay, so there's more testing that would have to be done to make the determination about which one is liked better or favored. Okay, but we're not going that far. Okay, for us, we've reached the end of the line. We're going to say they don't occur with equal frequency. We're done. Now, if you're the manager for the Mercedes-Benz Stadium, you probably want to know which one is favored or liked the most because you want to make sure you have it on hand. So you might go further, but for us, that's the end of the road. Everybody okay? It's a little bit different than what we were doing before. All right, let's try another one. I want to do another equal. This one says, a wedding caterer randomly selects clients from the past few years and records the month in which the wedding receptions were held. The results are listed below, are based on the data from the Amazing Almanac. use a 0.05 significance level to confirm that weddings are held in the different months with the same frequency. That basically is the same number of weddings every month. Okay? So that last statement there, that weddings are held in the different months with the same frequency. Again, notice you have that word same, which I hope makes you think of equal. And again, that statement there could become our null hypothesis. So our null hypothesis could be written as weddings, or we could even say all weddings are held in the different months with the same frequency. Again, because that implies that they're equal, that they're held in the months. Now, the alternative then, we would add the phrase, at least one wedding is held in the different months with different okay, we say that it's a different frequency. Okay, same, different, same, not the same. Again, the phrasing, again, each one of you could word it a little bit differently, but again, the null should always imply that it's the same frequency, or that it fits the distribution, or it doesn't fit the distribution. Okay, again, there's different words, different phrases, depending on which textbook author you look at, what researcher you're dealing with. So again, the idea there is that the null should imply equal, the same, and the null, or excuse me, the alternative should imply different or not the same, not equal. The data that we need for working the problem, remember, is this table. So there's step 2, there's our table. And the other thing we need is our significance level, which is 0.05. Again, I hope you recognize this as a chi-square goodness of fit, because we have qualitative data. We have the months of the year, January, February, March, April, so forth. Okay, so we have qualitative data. And again, nowhere in that description, in that scenario that's written there, does it talk about mean, which is the phrase to look for Z or T. Okay, so we're going to enter the data into Minitab. So we take our table and we're going to put it into Minitab. So I'm going to do that first. This time I'm just going to skip over and use, like, say, column 4 and column 5. I could erase the others, but it doesn't matter. So I'd have the month, and I would have January, February, March, April, May, June, July, August, September, whoops. Just want SCP, October, November, December. Okay, so I have all the months listed. Then we can call it weddings, how many weddings we had. or receptions. Okay, so then we would enter the numbers 5, 8, 6, 8, 11, 14, 10, 9, 10, 12, 8, and 9. Okay, so you get your data entered into Minitab. Then you go to the top, stat. Oops, stat. All right, I'm going to the wrong place. Stat, tables, chi-square, goodness of fit, one variable. This time I want to do the number of weddings, so I'm going to change it. And my categories are months. I have equal proportions. Now, we didn't figure out the equal proportion, but do you realize it would be 1 out of 12? You have one way to select a month out of the 12 months. Okay, Minitab's going to do that for you. So you can see that we should expect roughly 9 weddings per month if they're equally dispersed. Okay, scroll down. Here we have our chi-square, which is 7.38182. For now, I'm just writing down all of the numbers, okay? I do know that on your test, it may ask you to round to 2 places or 3 places. So my chi-square goodness of fit value is 7.38182. My p-value is 0.767. So I get that information from Minitab. Now, Minitab, again, gives you lots of stuff here, guys, because it gives you all of that. It can gives you some pretty pictures, but we're not getting that far into it, okay? So I've written down my answers from Minitab. Then I have to compare my p-value, which is 0.767, to alpha, which was given as 0.05. Making that comparison, 7 compared to 0. 7 is greater than 0, so p is greater than alpha, which means we fail to reject the null. And then the last step is to write your conclusion. So we would say at the 0.05 significance level, weddings are held in the different months with the same frequency. Now, hopefully that's obvious, because we said we would fail to reject the null, which means the null hypothesis is true, which is the statement that I wrote. I really hope you won't overthink it, okay? Again, it's the same hypothesis testing process, okay? It's the same process. You just phrase your hypothesis slightly differently, but everything else, the process is the same. Now, I want to switch gears and look at an example where you have different percentages. Okay, want to look at it where you have specific or different percentages. This question reads, in a recent study, the following percentages of U.S. retail car sales based on size were reported. 28.1% of the cars sold were small, 47.8% mid-sized, 7% large, and 17.1% luxury. A recent survey of retail car sales in Bartow County indicate that of the 100 cars sold, 25 were small, 50 were mid-sized, 10 were large, and 15 were luxury. At alpha equals 0.05, is there sufficient evidence to conclude that the proportions differ from those stated in the report? Now, this one looks a little bit different because it doesn't outright give you the table of information, but it does give you that information, and we could convert it to a table because it tells us we sold 25 small cars, 50 mid-size, 10 large, and 15 luxury. So if you needed to set up a table or wanted to set up a table, you could do that. But we begin with the same idea here, is we're going to state the null and we're going to state the alternative. Again, we could use the sentence that's there. Think about it. Proportions differ. Okay. I hope differ makes you think of not equal. Differ means they're not the same. So this statement that's highlighted in yellow is your alternative. Okay, so we could say the proportions differ from those stated in the report. Now, you may think, well, what report are they talking about? They're talking about the U.S. retail car sales, because we're looking at the population, remember, and the population would be the whole United States, not just Bartow County. That's our sample. Okay, so basically the sentence that I had highlighted in yellow becomes our alternative. And if that's our alternative, then the null would be that the proportions do not differ, because do not differ would imply they're the same or equal from those stated in the report. Okay, so that's your null. Now, I highlighted the information that you need in pink, but we're also going to need this information here from the report about the different percentages of car sales, because it's a different percentage for each category. So I have to know what those percentages are. We're not saying there that all the percentages are the same anymore. We have specific ones based on research. Okay. But again, hopefully you can recognize that this is a chi-square goodness of fit problem, because we have qualitative data. We have the categories of cars, whether it's small, mid-sized, large, or luxury. Okay, so again, we know That's how we recognize we're doing chi-square. Okay, there's a little bit of an extra step here when you go into Minitab, because we have to let Minitab know there are specific proportions. Okay, so you're actually going to enter for specific proportions, you're going to enter 3 columns of information. Okay, the first column will be your categories. The second column will be the observed. And the third one will be your percentages or your proportions, but they need to be entered as decimals. Okay, so we have to enter all 3 pieces of information. Okay, it's a little bit more to enter because we're not saying they're all the same anymore. So I'm going to skip over. It doesn't matter which column. So I have the size of the car. So we have small, mid-size, large, and luxury. Okay, then we have the observed, how many were actually sold in Bartow County. We had 25 small, 50 mid-sized, 10 large, and 15 luxury. Then in the third column, you can call it expected if you want to. I had 28.1%, so that's 0.281. Mid-size is 47.8, so that's 0.478. 0.07 for large and 17.1. Okay, so I've entered my percentages for what we would expect based on the report that are given to me in the problem, but I've entered them as decimals. Now, guys, if you don't remember, I'll make you a little note over here. To convert those percentages to decimals, you take your percentage and divide it by 100 to get your decimal, okay, if you don't remember. All right, then we go back, same commands. Stat, tables, chi-square, goodness of fit, 1 variable. Okay, my observed this time are in column 8. My categories are in column 7. But now, okay, notice I don't have equal proportions. Now I want proportions specified by historical counts. And I have to tell it where those counts are. They're in column 9. If I put my mouse in there, okay? So I have to tell it where are the observed values, where's the categories, and this time I choose proportions specified by historical counts, and I indicate where those percentages are located, or those decimals. Then I'm going to click OK. And again, Minitab does all the work. But again, notice up here, we observed 25 cars. We should have expected about 28. We sold 50 mid-size. We should have expected about 47, 48. 10 large, we would have expected 7. So it does all the work behind the scenes. It still gives us our chi-square. Okay, so my chi-square, goodness of fit, is 1.98686. And my p-value is 0.575. Minitab is doing all of the work for you. Write it down. So I wrote it down. Then you still make the decision, just like we did before. between P and alpha. We have 0.575 compared to 0.05. And I have 5 compared to 0. 5 is greater than 0. P is greater than alpha. If P is greater than alpha, we fail to reject the null. Which means for us, okay, again, thinking that through, we fail to reject the null. That means the null is true and the alternative is false. So what happened in Bartow County does seem to follow what happens across the United States. So we would say at the 0.05 significance level, the proportions of car sales in Bartow County do not differ from U.S. car sales. Now, I'll put a little bit more detail in there, okay? Because again, remember with statistics, guys, those details are important because it gives you that context. If I just say the proportions do not differ from those stated in the report, somebody comes along and reads that, they don't know what we're talking about. You know, are we talking about popcorn sales? Are we talking about weddings? Are we talking about car sales? So the details are important to fit, to fill in. So kind of put those adjectives and things in there that it's the car sales in Bartow County do not differ from U.S. car sales. Add the details. Now, ultimately, the test over Module 4, where you'll see this information and the questions you'll see on your practice problems and your homework, guys, they're multiple choice. So you have to pick which one you need. Okay, so the phrasing is kind of done for you. But you have to know which one to choose. Okay, questions? Okay. Let me remind you that